Okay, so we're going to do some multiplying polynomials, and there's some teachers that really care an awful lot about how you do it. When you get beyond, this class, get beyond the next class, and you get to an advanced placement calculus class, or you get somewhere else, it doesn't actually matter which way that you do it, as long as you do it accurately. So there's a lot of different methods that you can do to do it, but when we first start out with multiplying polynomials together, I am going to want you guys to do it by the method called the box method, where you draw out a box. And I know you guys are going to get super annoyed about having to draw this box every single time. But in the end, it will provide consistency amongst all the teachers as far as how we are looking at your guys' work, how we're grading it. But when you get to an advanced placement calculus class with me, I don't care how you guys multiply this stuff out. It will not bother me at all. So I'll show you when you get to that class other ways that you can multiply things out and still get the right answer and get it maybe a little bit quicker. But for now, unfortunately, I'm going to make you to draw the box. And your next teacher is probably also going to make you draw the box. So, okay, so we put our x minus 2 at the top, and then we put our x plus 6 on the side. And what we're going to do is we're going to do the multiplication table. So we go x times x gives me x squared. And then x times negative 2 gives me negative 2x. And then x times 6 gives me 6x. And then 6 times negative 2 is negative 12. And then what we're doing is we're adding across the diagonal. So I end up with an x squared, and then I end up with a 4x, because 6 minus 2x is 4x, and then I get a negative 12. And that's it. And what we're doing is we're getting this answer by multiplying it out. And in the end, next time, or the next sections that we're going to do, our next unit, we're going to take this simplified version and we're going to go backwards to where we started. Okay, but that's at a later time. I don't know why this doesn't say example 2. So now we do it again. And we have a 2a minus 12 and a 5a and a plus 3. So I get 10a squared minus 60a, 6a, and a negative 36. So again, we add across our diagonal here. So we have a 10a squared and a minus 54a and a minus 36. Again, multiply, because I'm looking for area. So I'm going to multiply this together. So 5y minus 5, 2y plus 6, so I get a 10y squared, a minus 10y, a 30y, and a minus 30. Again, add across my diagonal, so I have a 10y squared plus 20y minus 30, and that's equal to area. If I have a quantity square, this is the same thing as an x plus 6 times an x plus 6. You cannot distribute the square to both terms. The reason why is because, let's just say I had 4 plus 5, the quantity squared. This is 4 plus 5, we do parentheses first, which is 9 squared, which is 81. If I went and took my 4 plus 5 and I distributed my square to both terms, I would have ended up with 16, which is 4 squared, plus 25, which is 5 squared, and that is equal to, not 81, that is equal to 41, and those are not the same value. So you cannot distribute the square. So we will write an x plus 6 and an x plus 6, x squared, 6x, 6x, and a 36. So I get x squared plus 12x plus 36. Again, a 3g and a 10h. 3g, 10h, so that's a 9g squared plus 30gh. 30gh and a 100h squared, so 9g squared plus 60gh plus 100h squared. difference of squares. So I have an x and a 9y and a, oops, and an x minus 9y. So I have an x squared, a 9xy, a negative 9xy, and a negative 81y squared. Reason why it's called difference of squares is because the insides are going to cancel out. So I'm just left with x squared minus 81y squared. Okay. And that is it for this section.